come on. Hey there, Ravens. Welcome back to the third and final installment of Precipitation Reactions, describing precipitation reactions in aqueous solutions. Okay, the first one that we have listed here is the molecular equation. This shows the complete formulas of all the reactants and all the products and what state they are in, whether they be aqueous or solid. And we are particularly interested in the substance that becomes solid because that's our precipitate. Okay, notice it's a complete balanced reaction like we know how to do, we've always done. So molecular equation is exactly what you've always known. What's new is the idea of this complete ionic equation. The key word here, ionic. So you take your molecular equation and you break it down into your ions. Okay, and I'm going to get myself a pen here and let's see if we can, let's do black so what I write stands out. Okay, so lead and nitrate, when they're aqueous, are going to separate. And you're going to get the positive 2, the plus 2 of the lead ion, and then you get the NO3, which is a negative. But what about this 2 as a coefficient? Where did that 2 come from? It came from the subscript up here. Because for every one lead ion, there are 2 nitrate ions. So you need to put the coefficient 2 here to indicate that there are 2 nitrate ions. Same thing happens over here with the sodium iodide. There is a 2 as a coefficient, which translates down here, meaning that there are 2 sodium ions and there are 2 iodide ions. Okay? And over here, notice that the lead iodide, which is our solid, this is our precipitate, it's not written in ionic form because it is not in ionic form anymore. When it reacts, it becomes a solid and it is insoluble. It sinks down to the bottom and we don't have any lead ions floating around anymore, and there aren't any iodine ions floating around anymore. Okay? However, our sodium nitrate is aqueous. So therefore we have aqueous sodium ions, and again, because we have 2 sodium nitrate molecules, we will have 2 sodium ions and we will have 2 nitrate ions. Okay? So this is the complete ionic equation. Everything is just blown up and spread out. Last, the third type is a net ionic equation. If you work and get a paycheck, you understand the idea of net. Net is what you get to take home after you've been paid. Okay, you get to see all the taxes that get taken out. Okay, so net is what is really happening. In chemistry, we use net ionic equations to show what's really going on. Who's doing the changing, the reacting? Well, it's your lead ions coming together with your iodide ions to make the lead iodide. Another way to do this is to say, looking up here, going back to your complete ionic equation, is the lead ion on this side and on this side? No. What about 2 NO3s? 2 NO3 minuses over here, 2 NO3 minuses over there. They are not part of the reaction. They have not undergone any kind of change. They're identical. Over here, 2 positive sodium ions, 2 positive sodium ions. Again, they have not undergone any sort of change whatsoever. So that leaves you with the lead, the iodine, forming the lead iodide. Okay, and that's what we write in our net ionic equation. It allows us to simplify things and take out what's not changing. and so that we can focus on what is happening in the chemical reaction. Okay, I want to talk briefly here about spectator ions. The spectator ions are the ones that are just the spectators. They're watching, they're not participating. Okay, if you go to a football game, you are a spectator. You're not a player. So the sodium ions, the nitrate ions are your spectators in this reaction. Okay, so next slide, do it yourself. Pause the video and give it a try. This is great review as you begin to think about preparing for the final. Okay, welcome back. All right, so molecular equation. We have aqueous solutions. Get my pen. What color is it? It's black. Good deal. Okay, we have aqueous solutions of sodium phosphate. Oops, there we go. And calcium chloride are mixed together in an insoluble white solid forms. So we're going to have to predict the products here. Okay, so for my molecular equation, I'm just going to do what I always do. Okay, and I'm actually going to come up here and write my formulas so I can have a nice neat equation down below for you guys to see. Okay, so sodium is Na, and it has a charge of, right, +1. Come on, there we go. And phosphate is PO4, and it has a charge of -3. Right? So to get those to equal 0, that's going to be Na3PO4. So I can write that down over here under molecular. I am happy with that. Na3PO4. And again, this is aqueous because it told me in the description that it was an aqueous solution. And that is going to be combined with calcium chloride. Calcium Ca with a +2 charge, and chloride has a -1 charge. So that means I'm going to need 2 chlorines for every 1 calcium. So that's CaCl2. Okay, and an arrow, products. Sodium is going to combine with chlorine, and by now we all know that is sodium chloride. And next we have our inners, calcium and phosphate. Now I'm going to do these up here because that's not as easy. Calcium has a +2 charge, and phosphate, PO4, has a -3 charge. I need to get it to equal 0. So that's going to mean I'm going to need 2 of these, and I'm going to need 3 of these. So my formula will be Ca3 parentheses PO4 2. Okay. How do I know which one is the insoluble white solid? If you said go look at your solubility rules, you are spot on. Go looking at your solubility rules, you are going to find out that sodium is a group 1 alkali metal. It is always soluble. So sodium chloride is aqueous. Besides, you have had enough experience with salt, table salt, and water to know that it is soluble. Okay, phosphate is on the insoluble side, so when phosphate is combined with calcium, it is going to form an insoluble precipitate. So calcium phosphate will be the white solid that we'll see in this reaction. Am I done? It's not balanced, or at least I don't know if it's balanced because I haven't checked. Okay, well here's 3 sodiums. I only have 1 over here, so that needs a 3. Okay, and that gives me 2. This is a 3, not a 2. Okay, are we all happy that that got changed into a 3, giving me 3 chlorides over here. Oh my goodness, though, I have 2 of them over here. Okay, and I'm going to need 3 calciums. So that means this is going to need to be 3. So 3 and 2 is 6. So I'm going to have to cross that out, and this is going to look kind of ugly, but this is going to become a 6. Okay? That means I got 6 sodiums over here, and I got 6 chlorines. I got 3 sodiums over here, so I'm going to have to put a 2 here. That gives me the 6 sodiums and the 2 phosphates. 2 phosphates over here, and 3 calciums and 3 calciums, and 6 chlorides and 6 chlorides. So it's balanced, and it's looking pretty good outside of this ugly mess that's right here. That whole thing, that's just mistake, and pen doesn't have an eraser. Okay. So now we need to separate it out. The complete ionic equation. Well, sodium is an ion. So here's Na. It's aqueous, right? There's a Q, and it has a positive 1 charge. How many are there? 2 times 3 is 6. Plus the PO4 with its minus 3 charge, and it too is aqueous, and there are 2 of them. Okay? And then let's do the next compound. There are 3 calciums, which are also aqueous, with a plus 2 charge, and there are 6 chlorines, which are aqueous, with a minus 1 charge. And now I can do the arrow, and I now have, this one is aqueous, so that means it's separated out. 6 NAs that are aqueous and have a positive 1 charge, plus the 6 chlorines, negative charge, aqueous, plus my calcium phosphate. So let's see, I may even have to go down here a little bit. The Ca3 PO4, 2, and squeeze that S in there. It's solid. There is the correct complete ionic equation. And lastly, we have our net ionic equation. So, what things participate in the forming of the calcium phosphate? Well, phosphate does. So 2 PO4 with the minus 3 charge, and it's aqueous, plus the 3 calciums, plus 2, and it's aqueous, produce the Ca3 PO4 2 which is solid. And notice that it's always balanced. 2 phosphates, 2 phosphates, 3 calciums, 3 calciums. That's it. You just did that as practice. There are more practice problems in the book. This is also in your book, Chapter 8, Section 1 is what we're focusing on here. All right, and we have a lab coming up where you get to have some fun with all of this stuff. All right, thank you very much. Take care. Bye-bye.